All right, guys, welcome to today's class. Today we're gonna do a new chapter, which is basically number theory, but then we're gonna also do new chapter, which is three-dimensional figures. All right, so let's get started on problem 20. If the four-digit number 57D2 is divisible by 18, what is D? Well, from here we can notice that to be divisible by 18, first you gotta be divisible by 9. And divisible by 2. It's clearly divisible by 2, so all we need to do now is to make it divisible by 9. Well, what can D be? Adding all of this up becomes 14 plus D. And 14 plus D must be equal to the least common multiple of 19 that's greater than 14, which is just 18. So from here we notice that D is going to be 4. So the answer to this question is just 4. Alright, let's now move on to problem 21. What digit can replace k in the number 9k73k0 so that 9k73k0 will be divisible by 60? I'll let you guys have a try on this question and tell me the answer through chat. Alright guys, let's get started with this question. So basically, how do we approach this? Oh, notice that there's two K's in this. And we must notice that 60 is also divisible by 3. Specifically, 60 is divisible by 4, 5, and 3. To be divisible by 4, we need K0 to be divisible by 4. To be divisible by 3, we must have the sum of the digits to be divisible by 3. And the 0 means that the divisibility condition for 5 is already satisfied. So from here, notice that if we sum up every single digit, we get 19 plus 2k must be divisible by 3. Also notice that k must be 2 or 8. Looking at our choices, we notice that if k is 2, this gives you 19 plus 4 or 23. But notice that we have 2, 6, 8. 2, 4, 6, 8. Because all of these are divisible by 4. So not just 4. 2 times 4 is 8 plus 19 is 27. And from there we notice that, well, 4 works, follows all of these conditions. So the answer to this question is just 4 or A. Alright? Now let's move on to problem 22. I'll ask you guys have a try on this question in 10 minutes to chat. Alright, guys, let's get started with this question. So basically, how many different four-digit numbers can be formed using the digit 3, 2, 4, 5, 6, 7, so that the denoted repeat and the number is divisible by 4? Well, notice that since there's four-digit numbers, there only can be four possible choices. And notice that the only restriction is no digit repeat and the number is divisible by 4. And we note that the last digit must be even, so it can either be 2, 4, 6. From here, we find the digits that will make one of these three into a number that is divisible by 4. For 2, there's gonna be two possible integers, 7 and 5. For 4, there's gonna be three possible integers, namely 2, 4, 6. But since 4 cannot repeat, we must have only 2. For 6, the only possible integers are 7 and 5. From here, we notice that since we have three, so we can from here we can say there's three digits for the last one, and each of them only have two choices. And then we have three left. What can we do with the three? We have three choices for the first one, times two choices for the second. This just gives 2 times 3 times 2 times 3, or just 36. Right? Now let's move on to problem 23. Given that m and n are digits, what is the sum of the values for m and n such that the 5-digit number m679n is divisible by 72? I'll let you have a try on this question and time answers through chat. Alright, guys, let's get started with this question. So basically, notice that given that m and n are digits, what is the sum of the values for m and n such that 5-digit number M679N is divisible by 72? Note that M679N is divisible by 72. How do we do this? Well, 72 can be split into 9 times 8. So it has to be divisible by 8 and as well as 9. From here, we can notice that, well, all we need to do now is find 2 digits or 1 digit, which makes 79 and divisible by 8. But also, if we add a whole up, we get 7, 9, m 6, 7, n plus 6 plus 7 plus 9 plus n is divisible by 9. Let's get started with the 8 condition. Well, from here, we notice that if we test out all the values, we get 72 words. I'm at 7. We can let n be equal to 2 to get 792 to be equal to 72 times 11, which is indeed divisible by 8. Right? Notice that there's no other digit that will make 79n divisible by 8, so we can say n equals 2. Now all that's left is to find all possible values of n. Notice that since n is 2, we know that it could be 2 plus 9 plus 7 plus 6. Adding this all up gives you 16 plus 6 is 22, plus 2 is 24. Notice from here that n has to, the closest is 27. The closest multiple of 9 is 27. Notice that that's going to be 3 away, so m has to be 3 in this case. But we want to find all possible values, so what we can do is add another 9. But notice that the 9 can't, adding another 9 gives m to be 12, which is not a 1 digit. So what we do from here is notice that, well, since there's only one possible way for m and one possible way for n, or add them both up, we get answer of 5, or E. Now let's move on to problem 24. I'll just have to try on this question and tell me the answer to chat. Well, guys, let's get started with this question. So basically, how do we approach this? Notice that this is really going to be tough because we don't know what the tens digit is. We haven't learned a cycle. So how do we approach this? Such a cycle. How do we approach this? Well, one thought maybe think about the patterns it has. While the pattern it has with tens digit. Well, that's gonna be hard because we don't know what the patterns with tens digit. And we don't know how hard it'll be. So it might be a waste of time. So how do we approach this? Well, maybe we can think about it smartly. Or make a guess. Oh, because why? Because there's you can only notice that there's gonna be a pattern because we take a leap of faith, basically. All we do is just take out a bunch of multiples of 7 and powers of 7 and calculate them. So let's calculate them all. So first one is 4, clearly. Second one is 4. Second one is 4. Then the third one is 0. You put the first one as 0 because it's 0, 7 technically. From here we do 0, 4, 4, 0. And then it gets to 0 again. And then it goes to 4. Then goes back to 4. Then goes to 0. And repeats. And our leap of faith worked. What we took was a leap of faith actually worked, which will help you in a lot of competitions. Just take a leap of faith and hope you're doing it right. And if you're not, just do it another way. From here, we notice that, well, that's a cycle of 4, just like the units digit. So what do we do from here? Notice that the remainder when divided by 4 tells you which tens digit it is. This case, it's 7 to the 2011. What is 2011 divided by 4? Well, that's going to be a remainder of 3. From here, we get 1, 2, 3. So the answer is 4 or D. Alright, now let's move on to example 23. What value can A have to make A748 divisible by 36? Notice that, same thing as we did before. We split it into two integers that are relatively prime, 9 and 4. Now, some of the digits in this case have to be divisible by 9. And the last two digits must be divisible by 4. Doing this case where it gets the only answer for this question will be A equals 8. Since 11 plus 2 times 11 plus 2 times 8 is just 27. 4 times 8 is 48. 48 is divisible by 4. So the answer to this question is just 8. Alright? Now let's move on to our new chapter, or three-dimensional figures. Draw the three views of a three-dimensional figure. A three-dimensional figure can be represented by its three views: the front view, side view, and top view. To draw a top view, imagine a flying like a bird above the three-dimensional figure. So, what does that mean? Well, notice that this just means that you're just flying on top of the sky, looking directly downwards. Right? You draw. And then what if we're looking at the sides? The sides will just show you the sides. That's all it does. And so is the bottom. We just basically look at the bottom and see what it's facing out to you. Alright, so it'll make more sense when we do examples. Let's start with example 1. Draw the figure shown in front, top, and side views. Notice from here that if we look up as a bird and we look down right on the ground and saw the shape, what would it look like? Well, it would look like the top look like this. Alright, what about the bottom? If we flipped it over and looked at the bottom, we'll also see the exact same picture. Same thing if we looked at its back and the front. Back and front, so this way the bottom this way, and what else on top? All right, on top. So there's 4 possible ways. And there's 2 of these that look like this. A little staircase, basically. Like that. All right. Now let's do example 2 now. This will be a bit more difficult. So draw the front, top, and side views of the figure. Now notice that, same thing as before, the top, if we just look here straight down, this is just going to be looking as this. You'll see this. Right? Looking at it from the front, you'll actually only see this because this side, right over here, is also the exact same on this side. Alright? This tells you that this is part of that side, technically. And this covers the entire thing. That's just going to be looking like this. For the side view, it'll look like this figure. And the bottom view is going to be like this figure. Like this rectangle. Alright? It's going to be like this rectangle. Now let's move on to example 3. Draw the front, top, and side views of the following cell. Now this might be a bit more tough. Right? What does the top view look like? The top view will look like something like this. This is not, I will not draw the tiles. I'm just going to draw what it should look like if we draw it, looks at from the top. Should look like this figure with the empty thing in the middle. I should shade it in to show you what it looks like. It should look like a rectangle with like part of another rectangle then pulled out. Now, what does the side look like? Sides in this case look like this. One of them looks like this. Another one looks like this. Another one, this one right here, should look like this. Or there's only one tile here. One tile. And then last but not least, this one should look like this. With only 2 tiles and then 4. Give you a sense of idea. Now, what does the bottom look like? The bottom looks like the exact same as the top. So you only can see, you can basically see that, oh well, it's just basically the bottom basically the exact same as the top. But not every single figure, it has the bottom same as the top. Some figures don't, some figures do. Right? Oh yeah, for the front, we also have to include this part. I forgot, my bad. Because we have this towering over, so we're gonna see this one figure with that bottom. So there should be another one over here. Right? And so that's it. Now let's move on to example 4. Now we gotta draw the figure given that we have the front, top, and side views. How do we approach this? Well, notice that the top should look like this. So we know the bottom, or at least some part of it, has to be a 2x3. At most a 2x3. The bottom has to be a 2x3 at least, or the entire width is just 3. From the front, we know that it's gonna be like this, and the sides tell you it should be like this. Then we can see why that's true. Because from here, we know we can just make from here we can just notice that it has to be some sort of this shape. But notice that there cannot be an extra since it should be a 2x3, and we cannot extend more than that. Right? From here, we can say, oh, well, we can do, well, notice that this has to be, this is only two width apart. This has to be the exact same copies. This has to be the exact same copies. And the front of the cube, it doesn't necessarily have to be a brick of squares. So my bad. Doesn't necessarily have to be that. So notice that it should look like this because they should be the exact same copies of each other. They should be the exact same copies of each other. It should be like this, that, boom, and one more block like that. Should look like that. Since it follows all these criteria, so we know we just draw the correct figure. Since the sides have to be the exact same. There's only two tiles. So each of these tiles have to be the exact same size. Top is basically already done, and the front is also already done. Now let's move on to example 5. Unless you guys have a try on this question and try my answer to chat. All right, so basically, what do we do? So now, notice that. What is the man on the accused used to be build this figure? Now the left side looks like this, the top side looks like that, the front side could look like that. So Luke should look like something like this. About 4 blocks. There's gonna be a 3 block tower. And from here we can say, well, from here we notice that we see a tower. And then it should look like this. We should add in this extension. Actually, 2 digits, only 2 blocks. From there, we can just visualize it and then see, oh, this fits in perfectly. From here, we can say, now, how many blocks did we use? We use, this should actually be 2 blocks on top, a total of 3 over here. So from here, we can count how many we use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in this case, we used 11, so the answer is just D. All right, that's it for today's class. I hope you guys have a wonderful weekend and see you next week. Bye.